3 weeks from now, something will happen that humanity has never witnessed before. The interstellar object known as 3I Atlas will make its closest recorded flyby past Earth on December 19th, and the silence surrounding it is becoming impossible to ignore. For months, space agencies have promised clarity, high-resolution imagery, and detailed spectrographic data. Instead, what we've received feels like a slow drip of useless information. Blurred frames, delayed reports, and official statements that say almost nothing at all. The public expected answers. What they got was a fog. Atlas has already shown behavior that challenges our assumptions about how interstellar visitors should move. Amateur astronomers are capturing more detail from their backyards than billion-dollar spacecraft are releasing from orbit. Forums are filled with comparisons, side-by-side images, and questions that no one in authority seems willing to address. And as Atlas continues its approach, the tone of those questions is shifting from curiosity to concern. Even more unsettling is the timing. In late December, Atlas will disappear behind the Sun when observation becomes nearly impossible from Earth-based systems. That means the most active phase of its journey will be hidden from public view. Whatever it does during that window, outgassing, fragmentation, trajectory shift, we won't see it until after the fact. Government shutdowns, processing delays, and unavailable instruments are all being cited as reasons for the lack of updates. But when multiple independent space agencies go quiet at the same time, silence begins to look coordinated. Right now, Atlas is brightening faster than predicted. Its coma is expanding, its chemical signature doesn't match standard Comet models, and its path through the inner solar system aligns more precisely with gravitational assists than chance would allow. Each of these details could be explained away individually. Together, they form a pattern. So tell me in the comments, where are you watching from? Do you think we're being told everything about 3I Atlas? If this story pulls you in, leave a like and hit subscribe to stay updated as it unfolds. Because if not, December 19th may be remembered as the day our understanding of the cosmos changed forever. For weeks now, telescope networks around the world have been publishing and then quietly deleting imagery of 3I Atlas. Entire pages vanish overnight. Observation logs that once updated hourly have slowed to a crawl. Amateur astronomers report comet behavior that simply isn't reflected in official datasets. When these discrepancies are pointed out, agencies respond with the same vague explanation. Calibration errors. But how many calibration errors does it take before coincidence becomes strategy? Several independent observatories claim to have recorded unusual jets emerging from the object's surface, jets that do not match standard sublimation patterns. Within hours, the images were removed. The official statement: misidentified cosmic rays. Convenient. Meanwhile, citizen researchers keep reposting archived captures, and every time they do, burn patterns around the anomaly become more obvious. Even more suspicious is how certain telemetry pages have been taken offline entirely. These are not static public websites. These are real-time orbital data feeds used by academic researchers, students, and aerospace engineers. Their sudden disappearance has forced thousands of professionals into the shadows of private communication channels, whispering about restricted classifications and temporary access suspensions. The timing of these suspensions? Always within minutes of Atlas brightening events. And then there are the investigations. Quiet, internal, deniable. Several whistleblowers have reported that observatory staff have been instructed to reroute raw data to closed servers. Researchers who publicly questioned the official trajectory have found themselves removed from projects, cited for conduct violations, or reassigned without explanation. When knowledge becomes a liability, secrecy becomes policy. Telescopes capable of high-resolution spectra are suddenly under maintenance. University departments have been warned not to amplify unverified claims. Funding proposals that mention Atlas are delayed indefinitely. It feels like suppression, not caution. So ask yourself, if this object were harmless, why scramble so hard to control the narrative? Why lock down every lens pointed into the dark? Something is being hidden, something big, and the silence from above is louder than anything the data could ever say. By now, you've probably heard space agencies repeat the same comforting line. Atlas is just a comet. But if you look at the raw numbers, before they were quietly archived, its behavior reads like something out of a propulsion experiment rather than passive cosmic drift. Start with velocity. Comets entering the inner solar system tend to accelerate smoothly as solar gravity pulls them inward. Atlas, however, shows irregular speed spikes, brief surges that last minutes, not hours. They're subtle enough to hide behind statistical noise, yet consistent enough to form a pattern. Natural objects do not accelerate in discrete bursts. They respond to gravity like everything else in the universe. Unless they're helping themselves along, then there's rotation. Most comets spin unpredictably, slowed or nudged by solar radiation and outgassing jets. Atlas maintains a remarkably stable rotation rate, adjusting just slightly as it approaches thermal stress thresholds. Imagine a spacecraft adjusting momentum to maintain structural integrity. That's what these tiny tweaks resemble. It's the difference between tumbling debris and controlled torque, and the outgassing. This is where things get strange. Instead of the chaotic plumes you'd expect, Atlas exhibits directional releases from specific points on its surface. These jets appear synchronized with rotation, producing gentle course corrections. Traditional sublimation theory can't explain why emissions cluster at temperature minima rather than maxima, unless those vents serve a purpose, unless they're guided. Even more puzzling is the composition. Water and carbon dioxide are common, yes, but the ratio is unnaturally precise. Exactly the mixture needed for atmospheric alteration on a terrestrial planet. Engineers optimize ratios. Random rock and ice do not. Astronomers who've tracked comet behavior for decades are whispering about thermal signatures inconsistent with expected activity. You're not supposed to hear that. Not yet. If Atlas were behaving like a comet, we could ignore it. But comets don't steer themselves. They don't correct spin. They don't choose where to vent. Something out there is making decisions. Mark this date carefully, because December 19th isn't just another waypoint on Atlas's trajectory. It's the moment when several cosmic alignments converge in a way that astronomers are deeply uncomfortable discussing publicly. Start with Earth's position. On December 19th, our planet occupies a sector of its orbit that places us nearly perpendicular to Atlas's inbound vector. In practical terms, this means reduced parallax data and delayed triangulation. Our measurements become less accurate right when precision matters most. It's like watching an object approach from the corner of your eye. Visibility complicates things further. During the critical window, Atlas drifts into solar glare for large portions of the Western Hemisphere's observation arc. Telescopes designed to track faint targets lose contrast. Ground-based observatories hit atmospheric scatter limits. Agencies already anticipated this. That's why certain observation pages were quietly archived weeks ago. Then there's orbital intersection modeling. On paper, Atlas never crosses Earth's orbital path, but gravitational resonance doesn't care about paper. Small perturbations, Jupiter's influence, unaccounted radiation pressure, or those strange bursts of acceleration could nudge its path by fractions of a degree, and fractions are the difference between a harmless flyby and a near-miss trajectory that sprays volatile material across cislunar space. But the part no one wants to talk about, solar cycles. December 19th falls within a projected spike in solar cycle 25's magnetic turbulence. Increased coronal mass ejection probability, heightened solar wind flux. This could destabilize Atlas's coma, amplifying directional outgassing, pushing it into unpredictable behavior. Think steering thrusters caught in a gust. Now add the coincidence. The last three anomalous interstellar visitors, Oumuamua, 2I, Borisov, and Atlas, each aligned with solar activity peaks. Statistically, this shouldn't happen. Yet here we are again. Scientists aren't terrified because Atlas is dangerous. They're terrified because all the variables that normally smooth out chaos become chaotic simultaneously when orbital geometry, solar violence, and visibility collapse into a single date. That's when accidents stop being accidents. When Atlas reaches its minimum distance on December 19th, most people will be asleep. They'll never feel the shift. They'll never hear it, but instruments will. Machines always notice first. The first system to react will be Earth's magnetosphere. Normally, our magnetic shell deflects charged solar particles like a shield of invisible armor, but Atlas drags a dense coma filled with ionized dust and volatile gases. As it sweeps past, that cloud can interact with incoming solar wind, creating localized distortions, eddies of magnetism that ripple across Earth's upper atmosphere. Satellites positioned along the night-side arc could experience unpredictable turbulence, GPS drift, communication jitter, glitches that engineers will shrug off as routine anomalies. Then come the meteor streams. Every comet leaves behind a trail of particulate debris, most of it microscopic. If Atlas crosses Earth's orbital corridor with its current rate of outgassing, the planet could pass through a fresh band of material weeks later. That means meteor showers not predicted by established calendars, bursts of bright streaks over the night sky, cameras capturing sudden flares. Beautiful, harmless, except beauty hides the statistics. A single grain the size of a coin can cripple a satellite traveling at cosmic velocity. But the strangest signatures aren't visible. They're electromagnetic. As Atlas approaches, radio observatories already report broadband static, faint, whisper-like interference bleeding across multiple frequencies. It's not just noise, it's patterned, pulse intervals that do not correspond to known natural processes. When the coma densifies during closest approach, these signals may amplify. Ground stations could experience crossband contamination, where signals leak across channels that should be isolated. Some researchers think this will trigger auroral blooms at unusual latitudes, northern lights where northern lights should not exist. Others worry about resonance. If the electromagnetic spectrum shifts just slightly, power grids could experience harmonic imbalance, forcing automatic shutdowns to protect transformers. Most of this will pass without headlines. Engineers will blame solar weather. Astronomers will cite coincidence. But for a few hours on December 19th, our planet's invisible systems will bend, just slightly, to the presence of something not born of our neighborhood. Atlas is not the first uninvited guest to slip through our system. Twice before in modern history, interstellar objects have appeared, behaved strangely, and vanished into the dark. Each time, astronomers promised simple explanations. Each time, the data resisted them. The first was 1I Oumuamua in 2017, an object with no coma, no tail, no detectable outgassing, yet accelerating as if driven by invisible thrust. Its shape was elongated beyond anything previously catalogued, thin, reflective, tumbling, with a period that shifted subtly over time. Telescopes tracked it for weeks until its surface chemistry confused the models. Scientists quietly removed papers. Observatories archived pages that once highlighted its anomalous acceleration. When it left, it carried more questions than it delivered. Then came 2I Borisov in 2019. Unlike Oumuamua, Borisov looked like a classic comet, releasing gas and dust. But its composition was wrong. Its carbon monoxide levels were absurdly high, and its dust grains were unusually compact, as if engineered to survive interstellar radiation. As it neared perihelion, its behavior became chaotic. Jets fired in irregular pulses that altered its spin. Some researchers called it a chemical outlier. Others, less publicly, wondered if it was reacting to solar activity. Now, compare them to Atlas, where Oumuamua accelerated without visible physics. Atlas decelerates, subtly, deliberately, at distances where solar pressure has no measurable influence. Where Borisov's chemistry confused spectrographs, Atlas's signature seems curated, an engineered ratio of volatiles that just happens to support atmospheric thickening on a dry world. And most unsettling of all, timing. First, a silent scout, then a chemically rich courier. Now Atlas, carrying more complexity, more mass, and more precision than either of its predecessors. 3 objects, each within a decade, each demonstrating behavior that natural wanderers do not. Astronomy teaches pattern recognition. When you see one anomaly, you call it noise. When you see 2, you raise an eyebrow. When you see 3, all headed inward, all behaving against statistical expectation, you start to wonder if our solar system is not simply being visited, but prepared. For weeks now, observatories around the world have been struggling with something they refuse to name publicly. In press briefings, you hear careful language, unexpected discrepancies, instrument drift, processing noise. But behind closed doors, astronomers are describing something far more unsettling. Their instruments are behaving as if Atlas is interfering with them directly. It started with telemetry, deep space tracking arrays reporting micro-interruptions in data streams, tiny gaps that appear only when sensors are pointed near Atlas's current position. Normally, gaps like this resolve once atmospheric noise is accounted for. This time, the interruptions persist even in perfect weather, even when redundant antennas pick up the same anomaly. Data packets go missing as if someone is filtering them before they ever arrive on Earth. Then came the dimming. Optical telescopes capture brightness curves, the way a comet's reflected light fluctuates as it rotates. Except with Atlas, those curves flatten unpredictably. Light signatures vanish for fractions of a second, as if something is absorbing illumination rather than reflecting it. Astronomers compare it to a lens shutter closing mid-exposure. But that metaphor fails, because no natural object behaves like this. Rotation alone cannot cause temporary erasure. Spectral data should have solved the puzzle. Every comet emits a chemical fingerprint when sunlight heats its surface, revealing the molecules within. Instead, spectrographs are returning filtered spectra, entire wavelengths missing. The atmospheric signatures refuse to stabilize, and attempts to reconstruct the signal result in blank regions, like censored text. One researcher described the data as intentionally masked, then immediately asked reporters not to quote him. And the strangest detail, instruments positioned thousands of kilometers apart are failing in the same pattern at the same moment. Not random glitches, synchronization. When hardware from multiple agencies, across multiple continents, suffers identical blind spots pointed at the same target. There are only 2 possibilities. Either every observatory on Earth suddenly forgot how to measure light, or Atlas is broadcasting something we were never meant to read. Every comet carries a chemical story: ice, dust, carbon compounds, the frozen remnants of places we'll never visit. But Atlas refuses to fit that script. Its composition has become the single most controversial topic in planetary science, because if the measurements are accurate, this object is violating the rules of comet chemistry. Start with the carbon dioxide. In typical long-period comets, CO2 makes up a small fraction of volatile gases, usually overshadowed by water ice. But Atlas displays an 8-to-1 ratio in favor of carbon dioxide, a proportion far too high for any documented natural body. This mixture isn't just rare, it's optimized. In atmospheric engineering simulations, high-density CO2 plumes paired with water vapor trigger greenhouse reactions with uncanny efficiency. On Earth, this would be dangerous. On Mars, it would be transformative. Then there are the metallic inclusions, tiny flecks suspended inside the coma that should not be there. Mass spectrometers aboard orbiting craft detected trace alloys resembling lightweight aerospace composites. These aren't pure elements frozen in space. They're engineered blends with melting points that surpass natural mineral formation. You find this stuff in spacecraft heat shields and hypersonic surfaces, not inside comet tails. Researchers tried to classify the fragments as contamination until multiple agencies confirmed identical readings. And the whisper on encrypted academic channels, microorganic residues. Technicians analyzing dust collectors have reported polymer-like traces containing carbon webs arranged in repeating loops, structures not yet labeled as biological, but undeniably organized. Natural organics exhibit randomness. These do not. When 3 independent anomalies gas ratios, metallurgical composites, ordered organics appear in a single object, scientists are forced toward an uncomfortable conclusion. Nature can be chaotic, elegant, and surprising, but it does not optimize. It does not engineer. Atlas looks less like a wandering relic of another star and more like cargo, designed, delivered, on schedule. If Atlas behaves the way current models suggest, Earth will not remain untouched. Even without direct impact, a close interstellar flyby can imprint itself on our planet through subtle but measurable interactions. The first and most visible effect would manifest in the weather. When large cometary bodies shed dust and ionized particles, they seed the upper atmosphere. In rare cases, these particles act as condensation nuclei, triggering shifts in cloud formation. Sudden temperature inversions, unexplained cold fronts, and localized storm cells can emerge without the usual meteorological precursors. We have seen this before after major solar events, but the dust signature from Atlas is chemically distinct. It lingers. Then comes radio communication. The Comet trailing Atlas is heavily saturated with charged particles. As Earth rotates through that tail, our ionosphere could become more reflective and unstable, bending radio frequencies unpredictably. Long-distance communications might fade, distort, or fluctuate. High-frequency bands used by pilots, emergency services, and maritime traffic could degrade without warning. Operators will blame geomagnetic noise until they realize the solar cycle cannot explain the amplitude. And then there is orbital debris. Thousands of inert fragments circle Earth. Dead satellites, paint flakes, lost tools. Their trajectories are delicately balanced. Introduce a dense stream of microparticles with measurable momentum and watch chaos ripple outward. Slight changes in drag can shift debris fields by centimeters at first, but centimeters become meters over weeks. Collision probabilities spike. A single strike can create clouds of shrapnel that multiply exponentially. It's called the Kessler Cascade, and space agencies have quietly run simulations of what happens if a foreign dust plume nudges the system toward instability. None of this requires intent. It is enough for Atlas to pass close. Weather shifts, comms interference, orbital turbulence, small deviations that stack into something we are poorly equipped to manage. Earth may never take a direct hit. It doesn't need to. Proximity alone is pressure. When interstellar objects pass through our neighborhood, governments go silent first. Not out of ignorance, but out of strategy. Over the last 6 weeks, multiple national observatories have requested that their raw spectrographic data be reclassified. Pages that once published hourly readings now return error messages or redirect to archived snapshots with missing timestamps. The pattern is not random. It is synchronized. Closed-door committees have formed in at least 3 spacefaring nations. Staffers report unusual late-night briefings on orbital threat mitigation, language usually reserved for missile defense, not astronomy. Freedom of information requests are being denied under clauses referencing national security. That alone is telling. Meteor science is not a security risk, unless someone thinks this object might influence infrastructure. The absence of commentary is louder than any press release. Agencies that comment on every minor solar flare suddenly have nothing to say about a body arriving from outside our star system. Reporters receive polite declines. Scientists who were eager to speak in September are now unavailable for interviews. Those who do talk hedge their sentences with carefully chosen qualifiers, as if someone is reading over their shoulder. Meanwhile, budgets are shifting quietly. Parliamentary transcripts show abrupt increases in orbital defense allocations, millions rerouted toward kinetic interceptors, electromagnetic shielding, and debris tracking expansions. These projects usually take years of debate. Now they pass in minutes with bipartisan approval. No one explains why. Not publicly, international cooperation has become tense. Radar assets are being repositioned. A handful of satellites have been commanded into defensive polar orientations, a posture that makes little sense unless agencies anticipate ionized dust interference. Intelligence analysts whisper about space denial, scenarios. a term that should never appear alongside the word. Comet governments are not preparing for impact, they are preparing for uncertainty. And uncertainty at this scale is expensive. When objects like this enter our skies, there is something governments never say out loud. They do not need panic. They need witnesses. Not alarmed crowds, but quiet observers scattered across the planet, collecting data no agency can capture alone. And whether you realize it or not, if you can see the night sky, you have a role in this. The first step is simple. Step outside. Look toward the constellations where the trajectory has been plotted, starting near Sagittarius, slipping past Capricornus, and rising toward Pegasus. You do not need a telescope to notice brightness changes. You only need consistency. If you can, observe at the same time each night. Comet behavior is subtle, and patterns matter more than snapshots. Write down what you see. Is the coma expanding? Does the tail appear longer after solar wind spikes? Does color shift toward blue when it rises low on the horizon? Amateur records have revealed more surprises in the past decade than any government institution will admit. You are not a spectator. Your notes shape the timeline of this event. Point your phone at the sky, not to film, but to compare. Mapping apps reveal deviations in real time. If Atlas brightens suddenly, or dims when the solar wind eases, that is worth paying attention to. These fluctuations are not random. They tell us what energy is being absorbed, what material is being shed, and how fast the object is heating. Most importantly, stay curious. Follow magnetosphere indices. Watch aurora reports. If you live at lower latitudes and see sky glow where none should exist, mark the date. Dust activity could scatter charged particles through Earth's upper atmosphere. No heroics required, just eyes, patterns, and patience. Sometimes history is recorded by observatories. Sometimes it is recorded by anyone willing to look up when it matters. Whenever an interstellar object approaches Earth, space agencies quietly prepare for branches in the timeline, because there is no guarantee Atlas will behave the way the textbooks promise. And if you look closely at mission chatter, you can already see the outlines of their contingency plans. The first possibility is fragmentation. When a comet's core absorbs heat too quickly, the material inside expands faster than the shell can release it. Pressure rises, fault lines spread, and then it breaks apart. At first, that sounds like good news. Smaller pieces mean less mass, less gravitational influence, fewer electromagnetic interactions. But fragmentation creates swarms. Tiny fragments become micrometeoroids, fanning out along Earth's orbital path. Months later, those streams can arrive exactly when we are least prepared, igniting sudden meteor storms intense enough to threaten satellites and damage station shielding. The second scenario is trajectory drift. Atlas has already shown subtle vector corrections, too precise to dismiss as random jitter. If solar wind spikes or asymmetric outgassing increase, it could slide into a new orbital plane. A few tenths of a degree is all it takes to move a projected path thousands of kilometers at closest approach. Not collision level, but close enough to stress the magnetosphere, bend radiation belts, and send GPS satellites scrambling for recalibration. The third and strangest scenario is core exhaustion. A comet like this relies on volatile materials to maintain its activity. When those expel faster than predicted, the nucleus becomes inert. Behavior changes instantly. Instead of jetting outward, the coma collapses inward. Debris freezes. Rotation slows. To ground-based instruments, it looks like the object has simply died. But a dead nucleus can still drift silently into regions where we cannot track it accurately, becoming a dark object with unknown mass and unknown intent. No official statement will acknowledge these possibilities, but professionals know better. Space is rarely predictable, and objects that do not behave like comets tend to rewrite the rules when nobody is watching. Sometimes, the danger isn't in what arrives, it's in what passes by and refuses to act the way it should. When the public imagines danger from a passing comet, they picture the Hollywood version, a flaming rock punching into the ocean, tsunamis swallowing cities, dust clouds blanketing continents. But that is not how real threats work. Atlas doesn't need to collide with Earth to cause damage. In fact, the silent, indirect consequences are far more plausible and far harder to prepare for. Start with charged particles. As Atlas approaches perihelion, solar radiation strips electrons from the gases in its coma, creating a stream of ionized plasma that flows along magnetic field lines. When that stream intersects Earth's magnetosphere, it can warp the Van Allen belts, compress the bow shock, and funnel excess energy into our polar regions. The result looks like beautiful auroras. But below the atmosphere, power grids feel the surge like a kick to the ribs. Voltage regulators strain, transformers run hot. Satellites lose orientation as magnetometers drift several degrees off baseline. Behind Atlas stretches its dust tail, a wide plume of microscopic particles measured in nanometers to millimeters. If Earth's orbit intersects even the fringes of that debris field, those grains become high-velocity projectiles. They strike shielding like shotgun pellets. Most burn up in the atmosphere, unseen, but enough can reach the altitudes where our satellites live. Solar panels degrade, radar arrays pit, communication dishes lose reflective coherence. The damage is cumulative, invisible, until systems start failing all at once. Then there is the micrometeoroid threat. Fragmentation doesn't require dramatic explosions. A tiny crack, a pressure differential, a rotational stress. Atlas could shed hundreds of microfragments that disperse along its orbital path. Months from now, those fragments could intersect with commercial satellite clusters, punching holes through constellations we depend on for navigation, weather modeling, emergency communication, and financial transactions. No fireballs, just silence. That is the nightmare. Cascading outages, not cinematic extinction. Impact events announce themselves. Dust storms hide in orbital mechanics. Charged particles slip through magnetic seams. Micrometeoroids whisper through the dark until something important stops answering. The most dangerous threat is not spectacular. It is subtle, distributed, and patient, arriving one quiet failure at a time. If you've been watching the official channels, you've probably noticed the odd silence. Space agencies post vague updates. Press officers speak in rehearsed phrases. Government scientists smile tightly and talk about ongoing data collection. But beneath the calm exterior, something is cracking. There's a reason you're not hearing the full story, and it has nothing to do with incompetence. Start with psychological load. Humans are terrible at processing threats that are vast, invisible, and delayed. A world built on schedules and routines cannot absorb the idea of a cosmic variable entering the equation. Panic doesn't start with screaming crowds in the streets. It starts quietly, with subtle shifts in behavior, collapsing confidence, and a collective refusal to plan for tomorrow. Leaders know that once fear becomes ambient, it spreads faster than information. Then there's economic fragility. Modern financial markets don't react to facts. They react to uncertainty. The suspicion that December 19th might bring electromagnetic disturbances, orbital debris, or system-wide technological stress is enough to make traders freeze. Insurance models buckle, commodity futures swing. Satellite-dependent industries, telecom, logistics, defense, would see valuation drops measured not in millions, but trillions. Silence becomes a policy tool. As long as the public thinks everything is normal, markets continue to behave rationally. But the deepest reason for the quiet lies in geopolitical optics. If one government admits concern, every other government must respond. Budgets would shift overnight. Military postures would adjust toward orbit. False alarms become acts of aggression. Leaders would rather risk a silent surprise than trigger open competition for defensive resources, especially when no nation has the technology to influence the situation anyway. The unspoken truth. Authorities prefer citizens distracted. Festivals, sports events, seasonal sales, all are psychological sedatives. Better to keep eyes on screens than on the night sky. Better to let sleep come easily, even as something ancient and cold passes overhead. Silence is not ignorance, it's containment. Because if the world truly understood what December 19th might bring, nothing about our civilization would function the same tomorrow. December 18th, one day before closest approach. Across every time zone, the sky looks the same. Calm, indifferent, painfully ordinary. Cities breathe through yellow streetlights. Planes cross invisible highways. Power stations hum. And yet, for those who know what is coming, the air feels different, heavier, charged, like the moment before a thunderstorm that refuses to break. Inside the observatories, no one speaks louder than a whisper. At Mauna Kea, a technician rubs his eyes raw, staring at a line of data that refuses to stabilize. Every hour, the signal drifts a fraction. Every recalibration fails. In the silence of the control room, he swears under his breath and notes the time, 02:46 UTC. The stars above look unchanged, but the instruments disagree. At Alma in Chile, the software logs something it cannot explain, a repeating pattern at the edge of the detection range. The pattern appears every 108 minutes, like a heartbeat too faint to confirm. Half a world away, the Indian Deep Space Network reports a temporary coherence failure, then corrects itself with a line of code that no human wrote. Nothing crashes, nothing explodes, but everyone feels the hair rise on the back of their necks. The public sees none of this. On television, an anchor jokes about the Christmas comet, reading from a teleprompter written 3 days ago. Social media fills with filtered images of streaks across the sky. Half of them fake, half of them unexplainable. The algorithms push videos of winter markets, celebrity scandals, and countdowns to the new year. No one notices how many observatories have quietly gone offline for maintenance. Somewhere in a snowbound town in Norway, a man adjusts his backyard telescope. He has no degree, no funding, no press access. He just likes to watch the sky. At 22:19 local time, he captures a frame, a faint red object near the edge of the field, pulsing once every few seconds. He posts it online, tags it 3i Atlas, and goes to bed thinking nothing of it. By morning, the post is gone. In Florida, a child refuses to sleep, pointing out the window toward where the sky should be dark. "There's something moving," she says. Her mother laughs, closes the curtains, and whispers that comets don't move like that. Over the Pacific, a weather satellite loses orientation for 7 seconds. It comes back online, reports no anomaly, and erases its own error log. In Greenland, magnetometers register a mild fluctuation, too weak for an alert, too persistent to ignore. The readings spread in perfect rhythm across the hemisphere, like a breath the planet forgot it was holding. At NASA's Jet Propulsion Laboratory, someone refreshes a feed that no longer updates. The server still runs, but the stream is blank, just grey static. In the silence, the machines sound almost alive, like they're listening. By now, it is midnight in Europe. Clouds cover most of the continent, but above the layer of stormlight, the sky glows faintly orange. Amateur astronomers in Poland, Hungary, and Finland begin reporting diffuse halos, soft arcs of light too wide for auroras, too low for satellites. The reports vanish from their forums within an hour. Inside the European Space Agency's control room, a single monitor shows the trajectory curve flattening by a fraction of a degree. The math says impossible. The curve says otherwise. Someone quietly locks the door. Meanwhile, on the dark side of the moon, a probe wakes itself. It was not scheduled to. For 3 minutes, it transmits compressed bursts of raw telemetry back toward Earth. Noise, rhythm, silence. Noise. The file arrives corrupted. No one sees it until the next morning, and the night goes on. Trains run. Bars close. A storm breaks over the Atlantic. The hum of cities masks the quiet panic spreading through the small corners of science that still notice anomalies. At 03 ZAS UTC, the Canadian Balloon Project sends its final signal. Rising temperature, stable altitude, transmission loss. At 0302, the radio telescope in South Africa detects a narrowband spike aligned with Atlas's position, repeating every 9 seconds. At 0309, the International Space Station switches to secondary power for reasons under review. Then, silence. A silence so deep it seems to push against your eardrums. The world doesn't end. It just stops expecting anything. By dawn, every official channel posts identical messages. Nominal trajectory. No cause for concern. The phrasing matches across continents, even in languages that never translate the same way. At 0611 UTC, a tremor passes through Earth's magnetic field. A thin wave moving pole to pole in exactly 22 seconds. No earthquake, no solar flare, just a pulse, like something brushing past. A few people notice. An insomniac truck driver on the interstate. A radio hobbyist in Buenos Aires, an old woman in Kyoto who wakes to the sound of her wind, chimes ringing without wind. At the edge of dawn, the first observatories rotate toward the coordinates again. The data comes in clean, colder than before. Atlas has crossed into the final inbound segment. The instruments show an acceleration they can't explain. The comet is no longer just falling, it's adjusting. On every continent, someone feels the same chill without knowing why. Dogs refuse to go outside. Power lines hum just slightly higher. Airplane compasses drift half a degree east, then settle back. The night before the 19th passes without spectacle. No fire in the sky. No breaking news. Just an emptiness that hums like a held breath. In 100,000 data logs, the same timestamp appears. 0317 UTC, a flicker, a pulse, a silence. Tomorrow they'll say it was nothing. Tonight, every shadow feels like it's waiting for something to move. When the clock crosses midnight and the date finally rolls into December 20th, there won't be any fireworks or breaking news alerts. The world will exhale as if expecting a sound that never comes. The sky will look the same. Clouds will drift over quiet cities. Streetlights will hum in the cold. Somewhere, a telescope will turn a few degrees, and a single human eye will widen at what it finds. That's how cosmic events usually arrive, not with impact, but with implication. Not a single explosion, but a series of subtle mismatches between what we thought we knew and what actually happens. By morning, every observatory on Earth will be awake. Datasets will start to trickle in from optical telescopes, infrared arrays, and orbital sensors. Amateur astronomers will flood online forums, comparing brightness logs and parallax readings. A few of them will swear they caught something. An unexpected pulse, a brief shimmer in the dark field where the object should have faded away. Others will post empty frames, claiming the comet is gone entirely. Both will be right. At the Deep Space Network stations, the antennas will keep turning. They'll pick up faint radio noise, the kind that can't be traced to solar activity or atmospheric interference. A long repeating pattern, too regular to be natural, too quiet to be confirmed. Engineers will run correlation models, and each one will return a different result. Probably nothing, someone will say, even though everyone in the room feels the opposite. At research facilities, the coffee will run out before the certainty does. Data analysts will see fluctuations they can't account for, small but consistent, across multiple sensors. The ionosphere will show minor irregularities in density. Magnetometers will log faint, rhythmic deviations, and a few satellites will report brief, inexplicable drops in telemetry, as if something brushed against their signal paths. Most of the world will remain unaware. Traffic lights will change. People will check their phones, and daily life will continue its silent loop. But under the surface, the pattern will grow. Invisible, mathematical, undeniable. Governments will respond the way they always do. Quietly, bureaucratically, cautiously. Briefings will circulate with titles like preliminary post-event analysis and potential atmospheric coupling effects. No mention of Atlas. No direct admission that the models failed. Just enough language to sound in control. public statements will emphasize normalcy. No cause for concern, all systems stable, routine deviations. But inside, those same agencies' encrypted messages will tell a different story. Unexpected persistence, unverified emission data. Recommend continued observation. As daylight fades, more anomalies will appear. The auroras will stretch farther south than usual, glowing in colors the human eye doesn't often see. Violet, crimson, electric blue. Shortwave radio operators will hear strange harmonics in the static, like distant voices buried in white noise. And for a few minutes, maybe less, a subtle hum will ripple through the upper atmosphere, inaudible to most, but enough to make dogs bark and flocks of birds shift direction all at once. By evening, social networks will ignite. Posts claiming Atlas reappeared, videos showing light formations near the Terminator line, charts annotated in red circles and shaky lines. Half of them fake, half of them not. But it won't matter. The collective attention of millions will tilt skyward again, just as it did weeks ago. People will stand on rooftops, beaches, empty fields, phones in hand, eyes unfocused, hearts tuned to something they can't name. And amid all that noise, a few things will quietly change. The dust trail's chemical composition will deviate slightly from earlier readings. Trace metals where there should be ice. Electromagnetic signatures inconsistent with any known natural process. An orbital debris cluster will begin to drift, out of sync, as if tugged by a force too subtle to detect but too persistent to ignore. And one of the smaller tracking satellites, an unremarkable civilian probe launched years ago, will stop transmitting altogether. No malfunction, no debris collision, just silence. December 20th will not be the day of answers. It will be the day of questions that multiply faster than anyone can record them. If Atlas changed course, why? If the emissions persisted longer than expected, who or what sustained them? If the energy readings spiked precisely as Earth crossed its orbital node, what does that mean for the space between us? By the time the sun rises over the Pacific, a quiet panic will settle over the institutions built to explain the universe, because they'll realize something simple and terrifying. The data doesn't fit. Every model, every projection, every elegant equation, they all fail in the same small, stubborn way. And in that gap between prediction and reality, a new possibility begins to form. Some will say it's nothing, just statistical noise. Some will whisper that it's the first sign of contact. And some, the few who've been watching long enough, will see the truth. Whatever Atlas was, it wasn't finished when it passed the sun. It was only beginning. That night, the world will go to sleep again, half relieved, half restless. You'll close your eyes, thinking the story is over. But somewhere in the distance, a faint reflection will cross the edge of a telescope's viewfinder, too small to identify, too slow to ignore. And someone will write a message in a chat window that simply says, "It's still here." December 20th won't end anything. It will start something no one yet understands. No alarms, no breaking point. Just a whisper from the dark, saying, "We were never alone. We just weren't paying attention." You'll wake up the next morning with a single thought echoing quietly in your head. We're still watching the sky. And now, the sky is watching back. Before we move further, it's important to say this clearly. What follows is not prediction. It's speculation, structured, cautious, but still only theory. No one knows what 3i Atlas truly is, what it intended, or what kind of echo it may have left behind. But every major scientific discipline has begun running its own models, and though their conclusions differ, they all describe the same uneasy possibility. The event on December 19th was not an ending, but a fork in the timeline. This is not prediction. It's a thought experiment, a map of what could unfold if the object known as 3I Atlas had changed something fundamental as it passed. The scenarios are meant to explore possibility, not certainty. If they feel plausible, that's because science often lives on the edge of wonder. So remember, what follows the unknown is not fear, but curiosity, and curiosity is how we listen back to the universe. If we're right, these notes may serve as a map of what comes next. If we're wrong, they'll simply record how close we once came to understanding. It begins with something so subtle that most of the world dismisses it as nothing more than a minor glitch in an otherwise flawless system, a hiccup in the vast machinery of global technology that keeps our modern lives running smoothly. On December 21st at precisely 0411 UTC, every GPS satellite orbiting in low Earth orbit experiences a brief loss of coherence lasting exactly 0.7 seconds, during which air traffic controllers in Chicago watch in bewilderment as United Flight 214 appears to jump sideways by 300 meters on their radar screens, while pilots in the cockpits report their compass needles twitching erratically, almost like metronomes caught in a sudden, unexplained rhythm. The Federal Aviation Administration quickly issues a temporary recalibration advisory, assuring the public that the issue is under control. And by 0430, the anomaly has vanished as mysteriously as it arrived, leaving systems humming along once more. Yet, buried deep within the log files that no casual user ever sees, there remains a faint but unmistakable trace, a repeating pulse every 9 seconds, embedded directly into the carrier wave. A signature that matches exactly the faint whispers captured by radio telescopes back on December 18th, just before Atlas slipped behind the sun. At first, engineers attribute the disturbance to routine solar proton events, those bursts of charged particles that occasionally ripple through the magnetosphere, and software patches are rolled out across fleets of satellites and ground stations to prevent any recurrence, allowing daily life to slip back into its familiar patterns without much interruption. However, in the weeks that follow, subtle irregularities begin to emerge in places where precision is paramount. Self-driving cars navigating the crowded streets of Tokyo start experiencing inexplicable 2.3-second micro-naps at red lights, pausing just long enough to cause a ripple of confusion among passengers but never quite long enough to trigger a collision. And Tesla responds with a silent over-the-air update pushed to millions of vehicles worldwide, accompanied by no explanatory patch notes whatsoever. By January 3rd, the situation escalates when SpaceX's Starlink constellation suddenly loses 47 satellites clustered within a single orbital plane, with the official explanation citing a failed debris avoidance maneuver triggered by heightened solar activity. Yet internal autopsies conducted in secure facilities reveal something far more unnerving. The solar panels of the affected satellites are coated in a thin layer of iridescent nanodust that absorbs an astonishing 94% of incoming light, while their onboard telemetry streams have been completely overwritten by a rhythmic noise pattern repeating every 9 seconds. And astonishingly, these satellites continue transmitting data, though not to any Earth-based receivers but rather to one another in a complex language of phase-shifted pulses that defies all known communication protocols. The escalation reaches a chilling peak on January 12th at 3:17 UTC, when Europe's interconnected power grid succumbs to a harmonic resonance vibrating at precisely 0.11 Hz, causing massive transformers in Norway, Poland, and Spain to explode in eerie, perfect synchronization, plunging cities from Lisbon to Helsinki into cascading blackouts that last for 11 agonizing minutes before emergency protocols restore partial functionality. Investigators scramble to pinpoint the cause, eventually tracing it to an unnatural breathing pattern in Earth's own magnetosphere, pulsing in lockstep with an invisible external source located at Lagrange point 4, a stable gravitational pocket where no human spacecraft has ever been officially stationed, leaving experts to whisper about influences that originate far beyond our solar system's familiar boundaries. Meanwhile, the sky itself begins to transform in ways that escape the notice of anyone not paying extraordinarily close attention. As atmospheric layers high above the surface start absorbing and reflecting light in patterns never before recorded in meteorological history. On January 18th, weather stations across Siberia document nighttime temperatures plummeting a full 4.2 degrees Celsius below long-term norms, even as daytime highs climb unexpectedly by 2.1 degrees, creating a bizarre thermal sandwich effect that baffles climatologists and disrupts agricultural planning in one of the world's most fragile ecosystems. Deeper analysis reveals the culprit: a persistent stratospheric layer of carbon dioxide enriched with an isotopic ratio of exactly 8:1, an unnatural precision that mirrors the chemical signature detected in Atlas's expansive coma during its closest approach. Delivered to Earth via a steady rain of micrometeoroid dust that continues to sift down from the object's lingering debris trail long after the main body has vanished from view, in a twist that seems almost benevolent at first glance. The infamous ozone hole over Antarctica contracts by an unprecedented 11% in just 19 days, allowing harmful UVC radiation to penetrate deeper into tropical latitudes than at any point in recorded history, accelerating coral bleaching across the Great Barrier Reef by a staggering 300% and prompting governments around the world to issue vague statements attributing the changes to natural climatic fluctuations, even as marine biologists document entire ecosystems collapsing under the intensified solar assault. Stranger still, ethereal night rainbows begin appearing in skies across every continent, their colors arising not from ordinary water droplets, but from ultraviolet light scattering off suspended particles of metallic dust that glitter faintly under moonlight, while NOAA weather balloons ascending into the upper atmosphere capture samples of microscopic entities exhibiting shape memory behavior, contracting tightly at temperatures above +7 degrees Celsius only to expand dramatically below 12 degrees, where they proceed to self-replicate within cloud, condensation nuclei and seed the formation of artificial cirrus clouds that reflect sunlight with such efficiency that global temperatures drop by a measurable 0.3 degrees Celsius over the course of just 90 days, forcing the United Nations to convene an emergency climate summit under the cryptic agenda item labeled Unidentified Geoengineering Event. The most dramatic atmospheric shift arrives without warning on June 21, 2026, the summer solstice, when worldwide temperatures plummet by 1.1 degrees Celsius in a mere 48 hours, causing ice to form across the surface of Russia's Lake Baikal in the height of what should be midsummer warmth, while Arctic sea ice expands by an astonishing 22% in a single month, defying every predictive model developed over decades of polar research. Satellite imagery reveals the mechanism behind this rapid cooling. The same microparticles have begun self-assembling into vast hexagonal lattices within the mesosphere, creating a faint but unmistakable glowing grid that stretches over both poles and pulses subtly every 9 seconds when viewed through infrared filters, prompting NASA to release a terse official statement dismissing the phenomenon as nothing more than an atmospheric optics anomaly, even as private observatories capture data suggesting the grid is actively modulating incoming solar radiation in ways that no natural process could achieve. As the physical world grapples with these escalating anomalies, the structures of human governance respond with a mixture of denial, suppression, and frantic preparation, transforming silence into an official policy designed to maintain order at any cost. On February 14th, the Chinese government declares a nationwide cosmic emergency protocol, mandating the immediate registration of all amateur telescopes exceeding 20 centimeters in aperture, and dispatching security teams to confiscate equipment from anyone suspected of unauthorized skywatching, an operation that culminates in the disappearance of 3 prominent citizen astronomers mere hours after they upload spectral data indicating that the Atlas nucleus has fractured into 7 distinct fragments, each now accelerating along independent trajectories that no gravitational model can fully explain. Less than a month later, on March 8th, the European Union enacts the Sweeping Sky Integrity Act, imposing fines of up to €500,000 for the publication of any unverified orbital data, while compelling major social media platforms including YouTube, TikTok, and X to demonetize all content tagged with Mega 3i Atlas and training their AI moderation systems to flag the word Comet itself as a sensitive keyword, likely to incite public unrest. In the face of such coordinated suppression, public reaction settles into a comfortable apathy for many, with citizens scrolling past filtered news feeds and algorithmically curated distractions that bury astronomical anomalies beneath layers of celebrity gossip and seasonal sales, allowing governments to breathe a collective sigh of relief as daily routines remain largely undisturbed. Yet beneath this veneer of normalcy, underground networks of determined skywatchers begin to coalesce on encrypted platforms like Signal and Matrix, as well as hidden corners of the darknet, where data vaults hosted in geopolitically neutral locations such as Iceland, New Zealand, and Chile accumulate terabytes of raw observations that official channels refuse to acknowledge. Whistleblowers from within NASA's Jet Propulsion Laboratory leak server logs revealing continuous tracking of an entity designated Object 7, which alters its orbital parameters every 108 minutes with a precision that suggests active propulsion rather than passive drift, prompting the United Nations Security Council to convene a closed-door session under the ominous title Non-Terrestrial Influence Mitigation. While publicly maintaining that no extraordinary measures are necessary, the tension reaches a breaking point in November 2026, coinciding with the US midterm elections, when a classified memo surfaces showing that the Pentagon has quietly increased its orbital defense budget by $47 billion without any congressional vote or public debate, funneling the funds into the rapid development and deployment of kinetic interceptors capable of neutralizing threats in low Earth orbit, alongside advanced electromagnetic shielding systems and expanded debris tracking networks that bear a striking resemblance to anti-satellite weaponry. Russia, China, and India respond almost immediately with parallel programs of their own, conducting what they describe as routine debris cleanup operations that conveniently test asset capabilities in the process, transforming the silent vacuum of space into a shadowy battlefield where no shots are officially fired, but satellites from rival powers begin nudging one another off course with calculated precision, escalating the risk of accidental cascades that could render entire orbital lanes unusable for generations. While political maneuvering unfolds in sealed briefing rooms and encrypted channels, the global economy reacts not with explosive crashes but with a gradual, paralyzing freeze that erodes confidence one transaction at a time. As early as January 5th, high-frequency trading algorithms operating across the Chicago Mercantile Exchange, New York Stock Exchange, and Tokyo markets detect an inexplicable 0.4-second lag in GPS-derived timestamps, triggering a cascade of automated sell orders that wipes out $2.1 billion in market value over the course of just 11 minutes before human overseers can intervene, prompting a joint statement from the exchanges blaming a mere technical glitch, even as investigators uncover traces of the same 9-second pulse embedded within the timing signals. Insurance premiums for satellite constellations skyrocket by 40% almost overnight, and while SpaceX stock dips a manageable 8% before recovering within days, the incident plants seeds of doubt that blossom into broader instability as the year progresses. By March 2026, communication giants including Iridium, OneWeb, and Amazon's Kuiper report persistent packet loss rates climbing to between 20 and 30% across their networks, forcing global shipping companies to reroute container vessels using manual navigation, methods that haven't been standard since the pre-GPS era and causing delays that ripple through supply chains for everything from electronics to pharmaceuticals, with the Baltic Dry Index, a key measure of bulk shipping costs, plunging 44% in a matter of weeks. Central banks respond with coordinated injections of $3.2 trillion in emergency liquidity to prevent a broader credit freeze, while investors seeking refuge from volatile traditional markets drive Bitcoin's value up by 300% as the ultimate offline asset, creating a speculative bubble that further distorts economic realities. The climax arrives in September 2026, with what financial historians later dub the 9-second crash, when every major stock exchange worldwide halts trading for exactly 9 seconds in perfect synchronization, resuming only to reveal catastrophic losses. The Dow Jones Industrial Average down 31%, the Shanghai Composite down 42%, while cryptocurrency exchanges go completely dark for hours, with countless wallets mysteriously emptied before refilling under entirely new private keys, resulting in an estimated $28 trillion in wealth vanishing from known ledgers, only to reappear in anonymous offshore accounts that no regulatory body can trace. In the aftermath, the International Monetary Fund declares the dawn of a post-trust economy where traditional financial instruments lose relevance and barter systems re-emerge in localized pockets even as quantum-resistant encryption. Protocols, once thought unbreakable, prove vulnerable to timing attacks synchronized with the ubiquitous 9-second pulse. Beyond the tangible disruptions to infrastructure and markets, the events surrounding Atlas begin to infiltrate the collective human psyche, manifesting first in subtle cultural shifts and eventually in profound psychological transformations that reshape how societies perceive reality itself. In the spring of 2026, mental health professionals worldwide report a 30% surge in diagnoses related to sky anxiety disorders, with patients describing an irrational dread of open night skies that disrupt sleep patterns and daily functioning, while pediatric psychologists note an alarming trend of children producing drawings that consistently feature comets adorned with watchful eyes or trailing tendrils that seem almost alive. Social media platforms, already constrained by new content policies, nevertheless explode with the viral The 9-Second Stare Challenge, in which users film themselves gazing upward for exactly 9 seconds and sharing the inexplicable emotions that surface. Feelings of connection, dread, or overwhelming vastness that linger long after the timer ends. For some, the anomaly sparks a resurgence of New Age spirituality, with self-proclaimed cosmic midwives offering retreats centered on comet attunement ceremonies, involving crystals, sound baths, and guided meditations designed to align personal energies with the interstellar visitors' lingering vibrations. Others form more insular communities known as the vigil cults, gathering on urban rooftops in abandoned shopping malls retrofitted with salvaged telescopes and Faraday-caged hoods crafted from tin foil and conductive fabrics, where members meticulously record pulse patterns in shared notebooks and claim that fragments of Atlas communicate directly through their dreams, in fragmented visions of red light and geometric patterns. The phenomenon peaks in 2028 with an event dubbed the Great Wake, a mass psychogenic episode affecting an estimated 7.2 million people across every continent who simultaneously experience an identical lucid dream in which a crimson comet splits into 7 fragments before a disembodied voice intones the words, "We are still here," with subsequent EEG studies confirming synchronized theta wave spikes occurring at precisely 3:17 UTC regardless of local time zones. The societal fallout is immediate and far-reaching. Global productivity declines by 14% as workers struggle with recurring insomnia and intrusive daydreams. Religious institutions experience unprecedented revivals, with new scriptures emerging under titles like the Book of the Seven Fragments, and governments worldwide enact bans on dream-sharing applications, amid fears that collective subconscious experiences could be manipulated for psychological warfare within the hallowed halls of academia and scientific research. The old paradigms shatter under the weight of data that refuses to conform to established theories, leading to a quiet revolution in how humanity pursues knowledge about the cosmos. Throughout 2026, funding for non-priority astronomical projects evaporates as major observatories redirect resources toward classified initiatives, with raw data from Atlas reclassified under the opaque designation National Security, Cosmic, and access restricted to clearance levels that exclude even tenured professors who once led the field. In the vacuum left by institutional silence, citizen scientists armed with affordable backyard spectrographs detect a previously unknown emission line at 942.3 nanometers that appears consistently in post-flyby observations, yet corresponds to no element or compound in any terrestrial database, sparking underground collaborations that share findings through decentralized networks immune to censorship. The turning point comes in 2027 with the anonymous release of the Prague Papers, a meticulously documented dossier, alleging that high-resolution imaging captured during Atlas's perihelion passage revealed the nucleus to be hollow, structured around an internal hexagonal lattice divided into 7 distinct chambers, one of which registered as completely empty upon closest approach, implying that the object may have functioned as a delivery vessel for cargo or entities that were released into the solar system undetected. By 2030, the rebuilt Arecibo 2 observatory in Puerto Rico picks up a narrowband transmission originating from Lagrange point 5, consisting of a prime number sequence, followed by pi calculated to 1,000 digits, and concluding with a diagrammatic representation of DNA that incorporates 5 base pairs, rather than the familiar 4. Broadcast from what tracking data confirms is one of the 7 Atlas fragments now holding stationary orbit and exhibiting clear signs of internal power generation. The discovery births an entirely new discipline dubbed xenoarchaeoastronomy, though its foundational paper titled Evidence of Interstellar Terraforming Precursor is rejected by every major journal, briefly posted to archive, and then systematically erased from public servers, leaving only cached copies circulating among a dwindling network of independent researchers who operate under constant threat of professional ruin. The commercial space industry, once poised for explosive growth, finds itself navigating a minefield of contaminated orbits and unpredictable phenomena that turn ambitious expansion plans into high-stakes gambles. In 2027, a SpaceX Starship mission bound for Lagrange point 4 to establish a fuel depot is forced to abort when navigation systems fail catastrophically, with the crew reporting that for exactly 9 seconds, the star field outside their viewport appeared to shift positions, as if the laws of celestial mechanics had momentarily rewritten themselves. Lunar regolith samples, returned by subsequent robotic missions, reveal traces of the same metallic inclusions detected in Atlas's dust tail, but with an added twist. The particles demonstrate limited self-repair capabilities when exposed to vacuum conditions, fusing microscopic cracks through processes that mimic biological healing rather than simple sintering. By 2030, an unlikely coalition of spacefaring nations, including China, the United States, and India, launches the so-called Garden Fleet, a series of autonomous orbital platforms designed to rendezvous with and harvest exotic materials from the lingering Atlas fragments, only to discover that the fragments respond to proximity by growing at accelerated rates, self-assembling into larger and more complex structures that incorporate harvested components from the platforms themselves. One Chinese station transmits a final haunting image before going dark, a perfectly symmetrical sphere 3 kilometers in diameter now occupying a stable position at Lagrange point 5, its surface etched with hexagonal patterns that pulse faintly in synchronization with terrestrial anomalies. The awakening occurs in 2035 when the sphere emits a targeted gravitic pulse that nudges the Moon's orbit by 0.3 millimeters, imperceptible shift to the naked eye, but a seismic event in astronomical terms, accompanied by a multilingual transmission in 7 major Earth languages stating simply, "We were invited. You were not ready. We wait." The declaration triggers immediate evacuation of nascent Mars colonies, as mission planners calculate that any further interaction risks unpredictable gravitational cascading, while the Earth-Moon system is quietly declared a quarantine zone by an emergency session of the restructured United Nations Space Council, splitting humanity into two ideological camps: the grounders who choose to remain on the home planet despite the risks, and the exodans who accelerate plans for permanent settlements in the asteroid belt using propulsion technologies reverse-engineered from Atlas debris. Over the sweeping arc of decades and centuries, the echoes of that December flyby embed themselves into the very fabric of human evolution, altering biology, culture, and destiny in ways that unfold gradually across generations. Children born in the years following 2025 exhibit a 9% increase in melatonin sensitivity that grants enhanced night vision and, in rare cases, the ability to perceive infrared wavelengths unaided, prompting architectural trends toward domed ceilings and starlight, atriums that maximize natural illumination while fashion designers incorporate iridescent fabrics woven from synthetic threads, mimicking the light-absorbing properties of Atlas dust. By 2050, approximately 1 in every 7,000 births worldwide produces individuals dubbed pulse children, who display innate resistance to electromagnetic interference and an uncanny ability to synchronize their heartbeats when gathered in groups larger than 9, leading to their recruitment by space agencies for roles requiring intuitive orbital navigation that defies conventional instrumentation. The ultimate transformation manifests in the year 2100, with the identification of the 7th generation, a subpopulation comprising 0.3% of humanity whose genomes contain a novel 5-base codon insertion that remains dormant until activated by exposure to a specific radio frequency, pulse repeating every 9 seconds, the same interval that has threaded through every anomaly since Atlas's passage. Once triggered, these individuals experience brief telepathic bursts during intense auroral displays and share collective dreams featuring 7 crimson comets orbiting a transformed Earth, earning them the provisional species designation Homo Atlas in clandestine genetic studies that never see public release. As the final transmission from the Lagrange point 5 sphere reverberates through receiving stations one last time, the garden is ready. The gardeners return. The night side of Earth glows with perpetual auroras that dance in hexagonal patterns, while 7 red points of light maintain silent vigil in geostationary orbits, marking the moment when humanity's story ceases to be solely its own and becomes entwined with something ancient, patient, and irrevocably present in the space between stars. Governments, for their part, fell back on the oldest tool in their arsenal: containment. Official bulletins spoke in soothing generalities of post-event atmospheric stabilization and routine instrumental recalibration, while agencies quietly decommissioned aging monitoring stations across continents and replaced them with sleek new adaptive magnetometric arrays, a phrase that exists nowhere in any public scientific database, yet appears identically in procurement documents from Washington to Beijing. Press releases began to echo one another with eerie precision. The same carefully worded paragraphs translated verbatim into a dozen languages, evoking the synchronized, nominal trajectory, no cause for concern statements that flooded global feeds on the morning of December 20th. Somewhere behind closed doors, in rooms without windows, the silence was still being orchestrated. But silence is never absolute. It leaves residue. Faint, stubborn, impossible to scrub clean. Amateur astronomers refused to look away. From backyards in rural Argentina to high-rise balconies in Seoul, they charted subtle distortions at the ragged edge of the heliosphere, where the solar wind meets the interstellar medium and background cosmic rays bend into symmetrical gradients, as though refracted by something vast yet undetectable. When the coordinates were plotted, they converged on a single vector, the same quiet drift to which those orphaned Starlink satellites had been incrementally correcting their orbits for months. The implication was chilling. Whatever had passed through was not retreating into the void. It was repositioning. Speculation metastasized in the shadows. Mainstream voices dismissed the December pulse as a transient magnetic interaction between Atlas's ionized coma and Earth's magneto-tail, a rare but natural handshake amplified by collective anxiety. Others insisted it was nothing more than a calibration artifact, a ghost in the machine born of overtaxed instruments and sleep-deprived technicians. Yet a smaller cadre, methodical, insular, and increasingly isolated, refused to let the data lie. Ultra-low-frequency receivers, the kind used to monitor planetary hum and distant pulsars, continued to register a faint oscillation every 9 seconds, the exact cadence first captured by the South African Meerkat array in the final minutes before its primary systems went dark on December 18th. The pulse had embedded itself into Earth's electromagnetic baseline, a new heartbeat beneath the planet's skin. The scientific establishment faced an existential crossroads. To formally acknowledge the anomaly would require rewriting every foundational dataset in astrophysics, climatology, and precision electromagnetism. Decades of peer-reviewed constants suddenly rendered obsolete by a rhythm no model could predict. To ignore it was to sanction a slow, insidious drift from empirical truth, where the very tools of measurement began to lie by omission. Blue ribbon committees convened in secret, argued through encrypted channels, and dissolved without consensus. No one wanted to author the paper that declared the laws of nature might now be negotiable. In the absence of official truth, the public imagination, starved for narrative, did what it has always done. It invented. Fringe forums overflowed with elegant, terrible hypotheses. Some claimed Atlas had seeded a persistent field, a solar orbiting relay that harvested ambient radiation and rebroadcast it in modulated bursts. Others proposed the pulse was deliberate communication, a primer in an alien syntax we lacked the grammar to pass. A few, citing the precise 108-minute orbital corrections of the fragments, suggested the signal was a mirror, our own radio leakage from the dawn of broadcasting, flung to the heliopause and now echoing back with a 9-second delay. The time it takes light to cross the distance of one human breath. Most theories were ridiculed into obscurity. A handful lingered, too mathematically coherent to kill outright. By the spring equinox of 2026, the acute anomalies had subsided into a chronic hum. Satellites self-corrected. Ionospheric monitors returned to expected variability. The world, exhausted by its own vigilance, moved on to fresher crises. Yet those who maintained vigil, radio hobbyists in remote stations, geomagnetic researchers nursing obsolete grants, noted one stubborn invariant, the 0317 UTC synchronization spike. Every night, without fail, a microtremor rippled across global magnetometer arrays at the same universal second, too faint for headlines, too consistent for coincidence. Time itself seemed to carry a scar. No press conference announced the persistence. No emergency alert interrupted primetime programming. The story was buried beneath floods in Bangladesh, elections in Brasilia, and the latest celebrity scandal. But in the quiet precincts where patterns are currency, observatory basements, university sub-basements, anonymous repositories on the dark web, a realization took root and spread like frost on glass. Whatever had brushed past Earth in December had not departed. It had infiltrated the predictable, lodging itself in the trailing decimals of sensor readouts, the REM cycles of a generation, the static between channels, and so the possibilities remain unfinalized, branching like roots through soil we once believed. Sterile. Some name it contamination, an invasive residue rewriting the planet's physics 1 angstrom at a time. Some call it resonance, a harmonic lock between local systems and a distant, patient intelligence, and a few, in messages they encrypt twice and share only with trusted keys, dare to call it adaptation. Because sometimes the cosmos does not arrive to be witnessed. Sometimes it slips through the cracks to listen and to wait for the moment when the listener becomes the listen to, subscribe, hit the bell, because the sky didn't just pass by, it buried a seed. And on some quiet night, when the stars blink every 9 seconds, you'll feel it.